Let's get some directions, huh? We're going to get a little bit of trig, too. It might seem like it's been a while since we talked about sine and cosine too much, huh? We talked about the unit circle. Well, let's move into it. So we threw some hats on some vectors last time. Just kind of changed it up, and now we're going to talk about direction angles. And we can see that instead of, if we have a unit vector, so if we have a unit vector, right? Unit vector, we'd be 1 unit long, but we'd also be inside our unit circle, right? Our unit egg, whatever it is through there. So let's say we had a vector, and let's say it went into the second quadrant, but it's only got a unit, it's only got a length of 1. And we want to know what since we started out at 0, we could say that our vector is just going to be the same thing as that point because we started from the origin. If you take this down, this is your x value, right? This is your x value, that's your y value. But what would happen if you were to look at this and say the angle that came out? Well, that's not actually the angle, that's the reference angle. I'm miswriting it, but whatever, you get what I'm saying. It's going to be equal to our x value over our hypotenuse, which was 1. So it's actually just saying that it's cosine of theta. And then our y value is going to similarly work. It's going to be sine of theta, because sine of theta would just be this opposite side with the y value over 1, or just sine of theta is equal to 1. And we've learned that from back before. We already knew that. But now we're putting in here that x is equal to cosine of theta in the unit circle. X is equal to cosine of theta in the unit circle, and y is equal to sine of theta in the unit circle. So we can actually break them down into 2 pieces. So we're on the unit circle. Of course, measure clockwise, just counterclockwise, just like we learned in the past. Well, there we have it. Where we could say it's just cosine of theta times our I hat plus sine of theta times our j hat for a unit vector, 1 unit long. But that's not really going to be all that useful just to have a unit vector. I think what's going to end up being more useful is the fact is maybe, how do we do it? It's a 10 unit vector. Well, shit, it's not that big of a deal. However long it is, remember, this is just how long. Just multiply it by the components. We did it before. We're just going to bring it in and multiply by the cosine and the sine. That's our I hat or j hat. Or if you like the component form a little bit better, this piece just jumps into there, and we end up that it's however long it is. It was 10 when I was saying it, right? But now we got to write all these frickin' words in there, and then it just jumps on in. So, dude, this could really break some stuff down into some larger, more technical problems. So, let's see what we can do with this piece. Let's jump to an example, huh? Oops. Dang, come on. What if I told you we got an angle? It's 30 degrees. I know how long I want my vector. Let's make the vector, I want it 4 units long. So I give you the magnitude and I give you the direction. Shit, isn't that just a vector right there? But we have our new way of writing it, and let's have it. So our vector v is equal to, and maybe we write it in this way, that is just our magnitude times cosine of theta I hat plus the magnitude of vector v times sine of theta j hat. And we're going to move this around where we just keep the magnitude all the way on the outside, and we write it like this as well. A lot of frickin' notation, huh? So it looks like the pieces for us to be able to solve. We already got the magnitude, we're good there. We don't have to stress about the magnitude, but we do need to get cosine of theta and we need to get sine of theta, and we can create our own vector v with these 2 pieces of information. So let's go find cosine of our theta. Cosine of theta is equal to 30 degrees. Cosine of 30 degrees, we all know that one. That's root 3 over 2. And then we have to find sine of theta. Sine of 30 degrees, and that's equal to 1/2. Okay. So we can say that, all right, well, let's take our magnitude 4 and let's multiply it by our cosine of theta. Oh, no, I mean cosine of 30, our root 3 over 2 with our I hat. And then we're going to take our sine of 30, right? Because we had to have our sine value. That's going to go right into there. So our sine of 30, well, shoot, that's equal to 1/2. And then we clean it up by distributing it through. And that's the difference between the two. This one, I already have it distributed in. And the other one, I have it actually factored out. So once we bring it in, we find that our v vector is equal to 2 times root 3, right? Because the 4 and the 2, that cancels 2 root 3. I hat. And then half of 4, I'm pretty sure is still 2. And there we have ourselves a bit of a solution. We got it. We got ourselves a vector. Just by giving an angle and its magnitude. We can create vectors in this same manner. Now let's do another one, but let's mix it up just a tad. Let's say, oh, I know what we can do. Let's make vector v equal to, let's say 3 I hats. And let's go minus 3 j hats. But now the question is different. See, we went one direction. Given this piece of information, we wanted this piece of information. Now we want to go the opposite direction. Now, given a vector, I want to know 2 pieces of information. What angle does it point in? And how long is that dang vector? Huh? I want both those pieces of information. So we can play this game going back and forth, and this gets us a good understanding exactly what it means. So please be ready to play the game where, given an angle and a magnitude, I ask for the vector. Given a vector, what's the dang angle and the magnitude? You can get some practice inside your homework, especially with some of the word problems. Now the magnitude, shit, that's no big deal, huh? Let's just go get that first. That's just equal to, we take our components, we square them up, we add them up. So what's that, 9 plus 9? So I think that's going to be 2 times 9, right? 2 of them. So what's that, 3 root 2? Because what's the square root of 9? Remember, you can break things up like this. Square root of 9, isn't that 3 times root 2? Cool, we found the magnitude. The magnitude wasn't that big of a deal. But what is the angle. What direction are we pointing? We might want to draw a little bit of a picture, and I think this is the more complex part of the problem. What's here? Now, what's dope is we know how to draw a vector, don't we? So a positive x and a negative y, a positive x and a negative y. So this vector should be pointing down into the 4th quadrant. To that point, 3 comma negative 3. So there's our vector v. We want to know in which direction it's going. Now logic should tell you. Logic should tell you it's 315 degrees or negative 45 degrees, however you want to write it. I think we're going to try and keep it, where we keep all of our answers between 0 and 360 degrees or 0 and 2 pi. We'll keep it that way. Just by looking at it, come on, it splits it in half. Of course it's a 45. Of course it's a 45. But how would we go through and solve for it? How would we, given that we had some point at 3 comma negative 3, given that we know about this right triangle, do you think there might be a way for us to get this angle, given the fact that the opposite is negative 3 and the adjacent is 3? Opposites and adjacents. So in order for us to get our angle is going to be inverse tangent of your y value over your x value. And this is only in quad 1 and 4, because inverse tangent does not understand the 2nd and 3rd quadrant. It doesn't get it. There's a lot in this, a lot to unwrap. This is a very big piece. Hopefully you're getting it. Or theta is equal to inverse tangent of y over x. Oh shit, I forgot to write something. Oh, because what happens if you're a quad 2 or 3? It's only going to give you an answer over here, and you're going to have to move it to the other one. You actually just add pi in quad 2 and 3. There are other ways of solving for this. Your textbook, I believe, does it in a little bit of a strange way, but no big deal. So we're going to go get our y value and our x value. I think we can go get it from our triangle, our x and our y. Let's go pop it into here since we're in the fourth quadrant. And we can say that our angle is equal to inverse tangent of, and our y value is 3, negative 3, negative 3 is the y value, negative 3 over our x value, which is positive 3. So, oh, that's just inverse tangent of negative 1. And we all know how to find inverse tangent of negative 1. That's negative 45 degrees. Or negative pi over 4, depending upon how you want to talk about it. I'll speak degrees with you now. But let's keep our angle in between 0 and 360 degrees. Let's keep our angle, oops, we don't want that. Let's keep our angle in between 0 and 360 degrees. Oops. So what we'll do to this is we'll just take it and we'll add 360 to it. Negative 45 plus 360 is equal to 315 degrees. And that's how we're going to get that angle. This can be a little bit of a tricky game, but we're going to get to play it quite a few times throughout your homework. And any worksheets that I'm going to give you, I want to make sure you play the shit out of this game because I like this game. So more to come. Maybe we'll do a couple applied problems next. See you then.